Everybody's favorite, net-ionic reactions. Okay, these are reactions in solution. Reactions in solution. So we're going to take those ionic compounds that we already dissolved in water and we're going to react them together. So what I want to start with is an overall reaction. So this includes all of the ions, everything that's happening. So let's say we take calcium nitrate, and again we already dissolved it into water, so that's aqueous, and let's react that with sodium carbonate. Again, already dissolved in water. We're going to mix those two solutions together and we're going to get calcium carbonate, otherwise known as chalk, solid. Going back on our solubility rules, we know that calcium carbonate is insoluble in solution. So those ions are not floating around in solution. That's just a solid in our reaction. And then we're going to end up with 2, to keep it balanced, sodium nitrate. This is going to be in solution because it is soluble. Again, going back to our solubility rules. Okay, so that's an overall reaction. Okay, an overall reaction. Now, what a net ionic equation tells us is it tells us what is actually happening and what is just there to make sure that our compounds or our ions get into solution. Okay, so net ionic is going to tell us what's actually happening, not everything that's happening. So some of these ions are just here to make sure that the ions that participate get into solution. So what I'm going to do is I'm going to hack these apart. I'm going to split them apart into their ions, except for any solids, liquids, or gases. They don't split up, they stay together because they're not dissolved in solution. Okay, they exist as solids because they're not dissolved. So, assume all of these have aqueous next to them. So calcium ions in solution, aqueous. Nitrate ions in solution, aqueous. I think we have 2 of those. Keep it balanced for you. And then we have 2 sodium ions in solution. Again, pretend there's an aqueous next to these. And then we have carbonate ions in solution. Again, pretend there's aqueous next to that. Now on our product side, because calcium carbonate is a solid, it's going to stay together. It's not going to dissolve into its ions. It's not going to dissociate, so that stays together. And then we have 2 sodium ions. Pretend it says in solution. And 2 nitrate ions, again, in solution. So after all of those, you would mentally or physically, if you wrote this down, see AQ next to all of that. Okay, I want you to notice something very special. Here we have nitrate ions, 2 of them, and they look exactly the same on the reactant side and the product side. Something like that, if they're the same on reactants and same on products, those are called spectator ions. They're there to bring the other ions to the game, so the game can actually happen. A basketball game or football game would be pretty boring without spectators, I believe. Alright, so now we have the nitrate bringing the calcium ion to the game. Do you see any other spectator ions? Something that looks the same on the reactants and the product side. Oh yeah, check that out. Sodium ions, exactly the same. More spectator ions. Now, what we're going to do with the spectator ions, since they just brought the other ions into solution. Once they get those guys into solution, once the game's going on, they're really not needed. I mean, it makes it a little more exciting. But we don't need those in our net ionic reaction. Okay, so they're not really participating in the reaction, they're just dropping off the players. So our net ionic reaction, net ionic, actually is this. Calcium ions in solution, so aqueous, plus carbonate ions in solution, aqueous, yields calcium carbonate, solid. All right, there's your introduction or review of net ionic reactions. Let me give you just a few tips when you go through this, kind of the process that I use to go through this. Okay, step 1. If you have the overall reaction, split all ionic compounds into ions. I should say soluble ionic compounds. Soluble. So they have to be aqueous. Okay, so whatever has an AQ after it, that really is a Q. Never looks like a Q to me. Alright, you split those into the ions. Leave solids and liquids and gases together. We won't generally do this with gases, so leave solids and liquids together. And I will caution you, sometimes you'll actually see water as a product or a reactant. Not that something's dissolved in water, but actually water being a product or a reactant. It does not get split apart into its ions. Got it? Good. Leave molecular or covalent compounds, like water, together. So don't split them apart into the ions. So things like water or sugar or weak acids or weak bases, we're going to leave those together when we do net ionic reactions or net ionic equations. Okay, so that's all you need to know for now about net ionic equations.